Welcome students, myself SC Kunde from JDC Pitco English Medium High School, Nasik Road. Lesson first, laws of motion. Previously we have discussed motion, types of motion, then displacement, distance, speed and velocity. Now we are going to study uniform and non-uniform linear motion. Linear motion means the object travel in a straight line, that is called as the linear motion. And uniform linear motion means an object covers equal distance in equal interval of time, that is called as the uniform linear motion. Now observe this table. Amar, Akbar and Anthony are traveling in different cars with different velocities. The distance covered by them during different time intervals are given in the following table. Now see, the time in the clocks is given 5 to 5:30, 5:30 to 6, 6 to 6:30, 6:30 to 7, 7 to 7:30 and 7:30 to 8. The time interval is same, half hours time interval is given. Now in that the Amar covered distance, in first at 5 o'clock he covers 0 kilometers distance. Then after half hour he covers 20 kilometer. Then again next half he cover 40 kilometer. Then next half he cover 60 kilometer. Like that way he covered distance, but the distance is equal. In every half hour he completed distance 20 kilometers. So there is in half hour distance he covered at least 20 kilometers in each half hour. So that is he covered distance in equal time interval, equal distance. And this is the uniform linear motion. Now see, Akbar covers distance at 5 o'clock he covers 0 kilometer distance. Then at 5:30 he covers 18 kilometer distance. Then at 6 o'clock he covers 36 kilometer. And at 6:30 he covers 42 kilometers distance. In every half hour he has not covered equal distance. In first half he cover 18 kilometer. In second half he cover 18 kilometer again, and in third half he cover 6 kilometer. Like that way he has not covered equal distance in equal interval of time. So this is called as the non-uniform linear motion. Now in case of Anthony, which type of uniform motion is there? Now you find out that. Next topic is acceleration. Acceleration means rate of change of velocity. Acceleration is the vector quantity, have both magnitude and direction. You must have played on a slide in a park. You know that while sliding down, the velocity is less at the top, it increases in the middle and becomes zero towards the end. The rate of change of velocity is called acceleration. Now acceleration is equals to change in velocity divided by time. If the initial velocity is u and in time t, it changes to the final velocity v. So acceleration is equal to final velocity minus initial velocity divided. A is equals to v minus u upon t. If the velocity of an object changes during a certain time period, then it is said to have accelerated motion. An object in motion can have two types of acceleration. If the velocity changes by equal amount in equal time intervals, the object is said to be in uniform acceleration. And if the velocity changes by unequal amount in equal time interval, the object is said to be in non-uniform acceleration. These are the two types of acceleration. Positive, negative and zero acceleration. When the velocity of an object increases, the acceleration is positive and the acceleration is in the direction of velocity. When the velocity of an object decreases with time, it has negative acceleration. It is also called as deceleration. And its direction is opposite to the direction of velocity. And next, if the velocity of the object does not change with time, it has zero acceleration. These are the three types of positive, negative and zero acceleration. Distance time graph for uniform motion. The following table shows the distance covered by a car in a fixed time intervals. Draw a graph of distance against time time along the x-axis and distance along the y-axis. See in this table, time is given in seconds and distance given in meters. Time is given 0, 10, 20, 30, 40, 50, 60 and 70. And distance is given in meters, that is 0 to 15, then 30, 45, 60, 75, 90 and 105. Now see in time, 0 to 10, 10 seconds there, 10 to 20, again 10 seconds, 20 to 30, 10 seconds are there. In distance also, 0 to 15, 15 meters, 15 to 30, again 15 meters, and 30 to 45, 15 meters. So the time interval is same and the distance is also same. Therefore, an object in uniform motion covers equal distance in distance time graph for non-uniform motion. The following table shows the distance covered by a bus in equal time intervals. Draw a graph of distance against time, taking the time on the x-axis and distance along the y-axis. Now see in this table, time is given in second, 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30 and 30 to 35. And the distance is in meters. It is given 0 to 7, 7 to 12, 12 to 20, 20 to 30, 30 to 41, 41 to 50 and 50 to 58. Now see in time, 0 to 5, 5 to 10, that means the time interval is same, 5 seconds time interval is there, but the distance 0 to 7, 7 meters, 7 to 12, 5, then again 12 to 20, 8 meters, 20 to 30, 10 meters. So the distance is not equal. Such type of motion is called as the non-uniform linear motion. And the graph for non-uniform motion is not a straight line. Today we have discussed uniform and non-uniform motion, acceleration, positive, negative and zero acceleration, distance time graph for uniform motion, and distance time graph for non-uniform linear motion. Next topic I will discuss in next video.